going to take a look at what is bubble sort. To begin with, what is sorting algorithms? There might come situations when we want to order data in a specific order. For example, we have an array with lot of integers in it. Those integers are not either in the ascending order or in the descending order. But our goal is to make these elements either in the ascending or in the descending order. That's when a sorting algorithm will come in handy. Particularly, what is bubble sort? Bubble sort in C is a straightforward algorithm that checks and swaps elements if they are not in the intended order. Like, uh, it compares the two adjacent elements and find which one is greater or lesser and swaps them accordingly. Let me give you an example. This image explains bubble sort in a stepwise manner. Basically, a bubble sort will have two loops, an outer loop and an inner loop. Here, the outer loop is represented by I and the inner loop is represented by j. In this array, we have totally 8 elements, starting from the index 0 to 7. The outer loop will run from 0 to less than n minus 1, and the inner loop will run from 0 to less than n minus 1 minus I times. That's why we can see here the outer loop have gone from 0 to 6, that's n minus 1, that's less than n minus 1. Here we have 8 elements. So starting from the index 0 to 7, n minus 1 means 7, less than n minus 1 means 6. Here the outer loop gone from 0 to 6, and the inner loop will grow from 0 to less than n minus 1 minus I times. That's why in the first iteration the inner loop gone from 0 to 6, and in the next iteration it's from 0 to 5 because the I got incremented to 1. And the next iteration I got incremented to 2, j is reduced to 4, and to run accordingly, like I to 3 and j is reduced to 3, I incremented to 4, j is reduced to 2, I got incremented to 5, and number of times j will run is reduced to 1, I to 6 and j to 0. Here you can see that for every iteration of I, there is an element finding its position, like the maximum element is moved to the rightmost element. Here our motto is to arrange elements in an ascending order. That's why the maximum element is moved to the rightmost element. If you want to arrange the element in a descending order, the least element is moved to the rightmost element. We can think like for every iteration of I, the number of elements represented by jth loop, that is the inner loop, finding its maximum element or the minimum element and moving it to the rightmost element. We can see like in this array the maximum element is 9 and it's moved to 8. In the next iteration the maximum element represented by j is 8. That's why the 8 is moved to the rightmost element. In next iteration 7, 5, 4, 3, 2 and 1. This is how bubble sort works. If we look deeper, in the first iteration of I and j, when j equal to 0, the first two elements are compared whether they are lesser or greater than each other. Here our motto is to arrange the element in an ascending order. So we have to check whether the first element is less than the second element. So we will check 5 is less than 3, so it's false. So we have to swap these two elements, 3, 5, and the remaining elements will be as in the previous array, 1, 9, 8, 2, 4, 7. Okay. In the next iteration of I, the next two elements will be checked whether they are less than each other. That's 5 less than 1, it's false. So these two elements will be swapped each other, 3, 1 and 5. See, the 5 and 1 are swapped each other, 1, 5, 9, 8, 2, 4. The remaining elements will be same. It will go up to n minus 1 minus I times. In the after this first pass, the element which is greatest is moved to the last element. In the next iteration, the element which is greatest in this array, in this sub array, is moved to this position. So in every iteration of I, the element which is greatest in this sub array represented by j is moved to the rightmost element. That's a lot of theory part. Let us move to the programming section and how to program this bubble sort in C language. First, let us declare an array and initialize it with some integers 3, 4, 6 and 1, 2, maybe one more element, right? 0. That's it. There are 6 elements. 1, 2, 3, 4, 5, 6. Nextly, we need to know the number of elements in that array, right? So we can use the size of operator, size of array divided by the size of ARR of 0, array of 0. This will return us the number of elements in this array. In the next step is to declare two variables for those two loops, outer loop and inner loop. Next step, the outer loop, right, will go from 0 to less than n minus 1, and the inner loop will go from j equal to 0 to j less than n minus 1 minus I, right, and will get incremented in each step. Here we have to compare two adjacent elements. For that, ARR of j, and we have to compare ARR of j plus 1. If we need to arrange the elements in an ascending order, the first element should be less than second element, right? So when we have to swap those two elements, when the first element is greater than second element, that's how we can achieve ascending order, right? We can use a temporary variable to store an element, and swapping those elements, ARR of j plus 1, and that j plus 1 element will be equal to t. This is how we can swap two elements with a temporary variable. I think we completed bubble sort. So let us print those sorted array, and let's have a print statement which prints those elements. Let us have a space just for formatting purpose, ARR of I. I think we can run this code. Run. See, it got sorted, right? The elements here are 3, 4, 6, 1, 2, 0. After this sorting process, the elements get arranged as 0, 1, 2, 3, 4, 5, 6. Those elements within the array are sorted in an ascending order. If you want to sort those elements in a descending order, you have to just change this symbol to less than. This is correct. So in the descending order, the first element will be greater than the second element, right? So when we need swapping, when the first element is less than the second element, let us run this code. See, now those elements got arranged in a descending order. Here there is a drawback. Even though those elements are already sorted, like we initialize this array with sorted elements like 1, 2, 3, 4, 5 and 6. Even though these elements are already sorted, when we try to sort this array with this algorithm, these two loops will get executed until those conditions like I less than n minus 1 and n minus 1 minus I will get failed. So to reduce this extra looping steps, we can have an extra variable swap, initialize it to 0 and change it to 1 when a swapping occurs. Then at the end of the j iterations, we can check like whether at least one times swapping takes place or not. So we can check like if swapping equals to 0, this means that at the end of jth iterations there is no swapping takes place. So we can break these two loops. It will reduce the number of times the looping takes place. It reduces the unwanted looping process. You can ask like how this extra variable will reduce the number of looping steps. First let us run this code and check whether it gives the same result. See, it gives the same result that we require. That is in the descending order, right? So let me explain it. Let us go to the example part. Here you can see that while traversing the array, at least one swapping is required to indicate that there is some elements are unsorted. If the array is traversed entirely without a single swap, it indicates that the elements in the array are already sorted. So that's what we did in our code. Here you can see that we have initialized a variable with 0 and changed that value to 1 if there is a swapping takes place at least one times, right? So if the swapping doesn't takes place at least one time while traversing the entire array, it will break those two loops, so that it can reduce the number of times the looping takes place. It's an optimized code for bubble sort. That's it for this video. Thank you.